small, very small proportion. Okay, ionization in ammonia is suppressed. Okay, so there is a relatively high concentration of unionized ammonia. Okay, since there is OH minus form, this will be an alkaline buffer solution. Okay, so ammonia, when you add acid, think which one will it react first, with ammonia or NH4+, NH3 or NH4+. So if you add acid, it should react with the NH3. So most of the H plus is removed, you have less NH3, slightly more NH4. Okay, with OH minus, you will react with the NH4 plus, then you get NH3 plus water. Okay, so you add small amount of H plus or OH minus to buffer, it gets neutralized. Okay, so the H plus or OH minus doesn't increase significantly, so the pH is approximately constant. Okay, so I think it highly unlikely that you would have tried this before, because it's usually middle-aged people that will take this. Where you all know what this is? It's an extremely unpleasant condition. Basically, what happens is that your stomach acid backs up through your esophagus. Okay, it can. I've had it quite badly a couple of times. I actually asked my doctor, was I having a heart attack? Because it's that painful. Then my doctor told me how to detect the symptoms of a heart attack. Apparently, in heart attack, you must go down to your leg, the pain, and it's a particular thing. So he was trying to teach me whether it's symmetric, the pain is symmetrical or not. Okay? Anyway, basically, things like this. Okay, you have an antacid. Analgesic is a painkiller. Okay, so something like Panadol. Okay, aspirin is not Panadol. Aspirin is paracetamol. Panadol is paracetamol. Aspirin is something else. Okay, so now when you take aspirin, actually it can trigger this condition. Okay. So you put the antacid together to help neutralize the central stomach acid. Okay. If you have too much acid or base in the human body, it can cause heartburn or ulcers. Okay. So this helps resist changes in pH, preventing these symptoms from happening. I know all of this is of not very much interest to you because you haven't felt it yet. That happy state of conditions will probably last until you're 30. After 30, you may want to recall these lectures. Okay, but still you've got about 12 years more, so enjoy yourself. Okay? Now, so, you have, this contains sodium bicarbonate and citric acid. Okay? So, the sodium citrate will help to remove some of the stomach acid by forming citric acid. Stomach acid is actually quite a strong acid because it's mostly hydrochloric acid. Okay, so in the presence of the hydrochloric acid, the anion reacts and forms citric acid. Okay, and so it removes the H plus. I see I'm boring, really boring some of you. Okay, so I shall speed up. Okay, let's look at this now. How do we calculate the pH of a buffer solution? Okay, so there are two equations that you need to take into consideration. When I smile like this, it's generally bad news. I can smile because I know what's coming in. Yeah, September? Yeah, September. Okay, so the Ka that you write is going to be for the equilibrium. You don't, there is no equilibrium for the first equation. Okay? So, you rearrange it, you can get a H plus. You take log on both sides. Okay? For the bio students, this may be familiar to you. Familiar? No? Never learned this equation? Oh dear. Okay. Now, remember this because this is the equation that you need to use to calculate for the pH of a buffer. Alright? Now, when you consider, let's say, the buffer, which is made up of a weak acid and the salt, you need to look, as I said, the A minus comes from two sources. Okay? However, the A minus contribution from the acid is going to be very low because the A minus contribution from the salt suppresses the ionization of the acid. So essentially, the A minus concentration is from the salt. You can assume that it's only all from the salt. Alright? The HA, the concentration of HA, is because the dissociation of the acid is so low, is essentially that of the initial concentration. Alright? Just now when Nelson was asking how low is low, usually if you go and calculate all these values out, the values, there will be, for example, the HA from the dissociation is going to be 100 times less or more, sometimes more. Okay? So you can ignore it. Alright? Most of the situation, this thing, if you finally go to work out the exact values, you'll find that this is true. Okay? 2 to 3 SF is essentially, you can ignore it. Okay, so now, so take note of that. The A minus is concentration of salt, the HA is the initial concentration of acid. For weak base and the salt, it will be that. Okay? Okay, so let's look at example 3.1. Now, few things I want you to take note of. First, figure out, is this an acidic buffer or an alkaline buffer? Okay, so you see ethanoic acid and its salt is going to be weak acid and the base, conjugate base. So, you can do it two ways. One way is simply do it how you have been solving things. Use the Ka, use the ICE table, okay, to find the H plus and equilibrium and hence the pH. Now, first of all, since they give you in terms of grams of sodium ethanoate, you need to work that out. How much is it? Okay, how many more? Okay, and then what's the concentration? Okay, so you need to do that first. Second part. Okay, so here, when you look at it, you need to figure out what equation should you write. So remember, the salt ionizes totally, okay? And then the one with the equilibrium is going to be the weak acid. So you should write this out. Okay, so you put in the initial value. Okay? This is different from your previous example where you find the pH of a weak acid. Because here, the anion is a value and it's not zero. So okay? So that is what you need to take note of. The concentration of the salt is not zero. Okay, so you get the Ka equals to that. You make the assumption that it's small. Okay, then you can find what is the value of the Ka. So you can find out what is X and therefore what is the pH. Okay? Can? Okay. Second way, use this equation. Okay, if you can remember it, you substitute the values, you can get it very quickly. However, why would we want to teach you the previous method if this method is so easy? Because some of you may mess up this equation. Instead of a plus, you put a minus. Instead of the CH3COO minus over the acid, salt over acid, you do acid over salt. And then the values will come out very different. So, whichever way you prefer, if you think that you can do things fast enough, then you just want to rely on one method, use the method 1. If you are okay with remembering equations, use method 2. Okay? Alright? Okay. Now, calculate change in pH when 1 cm³ or 1 mole per cm³ HCl is added to the buffer. Okay, so for an acidic buffer, the pH is depending only on the concentration of A minus over HA. The Ka is a constant. Small amount is added. The HCl should react with the CH3CO minus. Okay? So go and find what is the CH3CO minus and therefore what is the CH3COH. Because as I showed you just now, when the CH3CO minus it reacts, therefore its final concentration will drop and then the final concentration of the acid will increase. Okay, so HCl added is there. Therefore, we assume there is a complete reaction. So, two things I want you to take note here because this is where people won't mess up. One, the amount has changed. Okay? CH3CO minus has decreased. The amount has decreased by 0.00100. Okay? That's the first thing. The other thing is the volume has changed, which you need to take note of. In this case, it's only 1 cm cube, but in other cases, it may be as much as 10 cm cube, 20 cm cube, so you need to pay attention. Okay? So, you have the new concentration. Okay? Similarly, for the acid, then you need to add in the new acid and the new volume. Okay? All right? Okay, so you get the new pH and you find that. Okay, so there's only a decrease of 0.05 units, which given pH is very small. Alright? So I have 6 minutes more, right? Okay, let's continue. Now, when you add sodium hydroxide, then you need to consider what reacts with sodium hydroxide. It should be the ethanoic acid. Okay, so then you need to find the resultant concentrations. Okay, so that equation will occur. Go and find out how much sodium hydroxide is added. Therefore, how much of the ethanoic acid is reacted. Therefore, what is the resultant of the ethanoic acid and the resultant of the anion, the ethanoic ion. And these are the new volumes. Okay? So, substitute those values into the equation and you can see that there is a pH change. It would have increased by 0.06 units. Okay? Okay, so let's look at 3.2. Now, you can, couple of things, you can try this. I want you to take note of some things. Here, you have, they give you solutions as opposed to previously, they give you a solid dissolved in a fixed volume. When you mix these two, the volume will change. So you need to take note. Okay? Okay, so try to work out that for ammonia. I'll show you the one for ammonia. Work out the value for ammonia. So, work out the amount divided by the new volume. Okay, can you finish this off at home? When the next lecture, I will run through very quickly the answer. Okay? Hey, take note.